Hey guys, welcome back. This is part 2 of our introductory lesson to basic trigonometry. So what we've got here, as just a reminder, is we've drawn our triangle and we've got our angle theta written down here in the corner, and according to where we've written theta, we can label the other three, we can label the three sides of the triangle. We can give them names. Now you could call them ABC, you could call them XYZ, you can call them whatever you want. For now we're using words because the words are going to make this really helpful when we start with making the actual functions. Otherwise you're just going to have, this new type of function equals, B over C or something, It's going to get confusing really quickly if we don't come up with a consistent system that you can use every single time. So if your angle theta is here, your adjacent side should be this. So your angle theta is made up using two sides of the triangle. One of those will be the hypotenuse. The other one will be the adjacent side. Okay, so there's two sides of the triangle. You can see this side right here and this side right here come together in this corner to make up our angle theta. Now, there's only one side that doesn't actually have anything to do with making up this angle physically, so that's the side that we call the opposite side. So your angle theta, we'll never call the right angle triangle, that's not the one we'll ever be interested in, because we know its value is 90 degrees. So your angle theta is always going to be made up of two sides, one of which is going to be the hypotenuse, and the other one is always going to be the adjacent side, and then you just call the last side opposite. So you can see, once again, if you just had a triangle but you were working with that angle, it's made up of two sides. One must be the hypotenuse, which is the one opposite from that right angle in the corner, and the other one has to be the adjacent side based on what we just came up with. So this thing down here must be the side that we would call the opposite side, but that's, again, only if we were working with this angle up here. We're working with the angle down in this corner, so the names of these two should be flipped. Does that make sense? So basically, this is the way our triangle is labeled. We've got adjacent, opposite, and hypotenuse. Now we're going to create some trigonometric functions. So the first one is called the sine function, S-I-N-E. Now, don't confuse the spelling with like S-I-G-N or something, but on a calculator you'll see this written as S-I-N. They've just dropped the E off the end. All of the trigonometric functions have these three-letter short forms that you'll see on a calculator, and mathematicians will only write the short form. So the short form for sine is S-I-N. Please don't pronounce it sin when you're reading it out loud. It's still pronounced sine. Okay? So you've got your sine function. You'd write it as sine of theta. You can put the brackets if you want, but you don't have to put the brackets. You could write it like this, sine theta, like this. This means that the value of sine theta, sine is this trigonometric function we're working with, it's a ratio. It's a ratio of the lengths of two sides of the triangle. Okay? So we've got the sine function, which is a ratio between two sides. Which two sides? Well, sine theta equals, it's the ratio between the opposite side and the hypotenuse. Okay? So this ratio of the length of the opposite side and the hypotenuse is sine theta. Okay? So this angle, theta, the measurement of the angle will always be the same if this ratio is the same. Okay? So if this angle was 30 degrees, then if we know the angle is 30 degrees, we can actually figure out this ratio of these two things. Now mathematicians have gone and figured out that, okay, sine of 30 equals something, and so we can use that answer so that if we can figure out the ratio, if we figure out the length of the opposite side and the length of the hypotenuse, then we can actually figure out sine of theta. Okay, so this might be a little bit confusing right now. What I'll do is I'll write out all the functions and then we'll work with them a little bit. So we've got sine theta is basically if you take the length of the opposite side, you take a ruler and you measure this, and then you divide it by the length of the hypotenuse, you have this ratio, sine theta. Okay? We're going to work with them a little bit later. Right now we're just getting an introduction to what the formulas are. Okay? These are the functions, these are the ratios that we're going to be using in this unit. Okay? So we've got sine theta, sin, and then the theta sign, which means the length of the opposite side divided by the length of the hypotenuse. The next one is called, I'll write it down here, and then after this I will give you a sec to write it and we will erase it. The next one is called cosine. The short form for cosine is COS. Some people will still say cosine, some people will say cos, some people will say cos. I don't really like it when someone says cos instead of one of the other two. Cos is fine, that's what I grew up saying, but whatever's most comfortable for you, go with that. So cosine of theta is the ratio between the adjacent side and the hypotenuse. So it's the ratio of the lengths of the adjacent side of the triangle, so this one, and the hypotenuse. Alright? So basically, if you know the length of the adjacent side and you know the length of the hypotenuse, you take this length, divide it by this length, and that gives you the value cosine theta. Basically, once you have that value cosine theta, now with calculators and stuff it's easy, but back in the day I didn't really have to go through this, but my teachers would have had to go through this, and some of your teachers might have. Basically, once you figured out cosine theta, you could look up in a table what the value of theta must be to give you that cosine value. So basically, if it said, I don't know, if it said something like, I'll give you an example after we do the third trigonometric function, but let me give you one now. So if it said your sine theta equals 1/2, okay? Let's say sine theta equals 1/2. You've done your measurements, you've measured this side and you've measured that side, and you get an answer of sine theta equals 1/2, or 0.5. You could look up in a math textbook, you could go to the back and see, okay, if I have the sine theta value as 0.5, what is the theta value? And the theta value for this is 30 degrees. So on a calculator, there's a way you can transform your answer for sine theta into the value theta, but for now, we'll just leave it at this. We haven't started actually working with the functions. I'm just trying to show you what the functions are. So we know our sine function is opposite over hypotenuse. We know our cosine function is adjacent over hypotenuse. Okay? And there's one more. You might see where this is going, you might not. I'm going to erase the sine one now, so that I have some room to write in our third one. Okay, so we've so far got our sine function, which is opposite over hypotenuse, and we've got our cosine function, which is adjacent over hypotenuse. So you measure the length of these three sides, and you can calculate sine of theta and cosine of theta. Alright, now the last one is called tangent. Short form on a calculator, if you're looking at a calculator, you might guess what the short form is. Short form is tan, T-A-N. You can just call it tan if you want, call it tangent if you want, both are fine. And tan theta, or tangent of theta, is opposite over adjacent. All right, so it's the length of this side divided by the length of this side. Okay? So, basically what that means is if you know the length of the opposite side and you know the length of the adjacent side, you can figure out tangent theta, and then you can use that information to find out theta. Incidentally, for the remainder of this unit, well, really for the remainder of the school year, for this unit and for the final exam, I recommend that you bring a calculator, and preferably a scientific calculator, one that will allow you to use the sine, cosine, and tangent functions. You can get more basic calculators that can't actually do that for you, and those won't really help you in the trigonometry unit. So we'll go through how all of these things work, but when it comes to doing examples, if you want to do practice problems, if I put anything up on the board that you want to try at home, you're going to need a calculator for some of those things, because your only other option would be to find a math textbook which has those big tables in the back of it, where you take your tan theta value and then figure out roughly what your theta value is. So instead of doing that, we'll use calculators for it. So from your next lesson onwards, basically bring in a calculator. All right. So let me give you an example of how this works in action. All right. So we know our sine value, the sine ratio is opposite over hypotenuse. So you measure this length, you measure that length, you figure out sine theta. You know your cosine value is adjacent over hypotenuse, so that's this side right here divided by this side right here. And then tan theta is opposite over adjacent, so it's this length divided by this length. Okay, so there's a lot of different things you can do with that. You might think, well, wouldn't it just be easier to get a protractor and just measure the angle if I want to know that? Yes, it would be easier, but this is just another tool you can use. Let's say you only had a ruler and you had a triangle sitting here and you knew this one was a 90-degree angle, but you didn't know the measurement of this angle and all you had was a ruler. If you measure these three sides, or if you measure any two of the sides, you can use one of these trigonometric functions to figure out what the angle is if you're well versed enough in trigonometry. So let me give you a brief example before we go. So basically, let's say you've got your triangle over here. We know that that angle in the corner, in the bottom right corner, is a 90-degree angle. That's the other thing. These three functions, sine, cosine, and tangent, I don't know if I said this earlier, they only work if you're working with a 90-degree angle. The way I've described it, this opposite adjacent hypotenuse thing, needs a 90-degree angle to be present in the triangle. Okay? So let's say we've got this triangle, and let's say we haven't measured the lengths of all three sides, but let's say we've measured the length of this side, and it came out to be, let's say, 10 centimeters. And let's say we measure this side, and it comes out to be 20 centimeters. Okay, so that's the hypotenuse. And then I got bored. I didn't need to measure the third side. I've only measured these two. Now let's remind ourselves of the three trigonometric functions. We've got sine theta, which is opposite over hypotenuse. We've got cosine theta, which is adjacent over hypotenuse. And we've got tan theta, which is equal to opposite over adjacent. Okay, now if you notice, I've measured the length of this side. If my angle is over here, this side is my opposite side. This side over here, because it's far away from the right angle, is my hypotenuse, and this side down here is my adjacent side. Now, this question could be asking for two things. If I give you the 10 over there, the 20 over there, and that right angle, I could ask you to tell me what this angle is, but then I could also ask you to tell me what the length of this side down here must be. So if you look at this, we don't have enough information to use the cosine function. We need the length of our adjacent side in order to use the cosine function. So this actually is not helpful to us right now. The tangent function is actually the same way. We need this length in order to do opposite divided by adjacent. We have opposite, but we don't have adjacent, so this is actually not helpful to us either. So far, the only thing we can use is the sine function. So we take opposite over hypotenuse, and if you do the math, you get sine theta equals the length of the opposite side, which is 10 centimeters, divided by the length of the hypotenuse, which is 20 centimeters, which, if you simplify it, equals 1/2, or 0.5. Alright, now we won't talk just yet about how to get from your sine theta value to your theta value, just because we're running out of time, but we'll end up talking more about this later. But basically, if your sine theta value, if sine theta equals 1/2, that actually tells you enough information that if you were to take one of those big tables and look it up, it would tell you that theta is 30 degrees. Okay, so in that way, you could figure out what the theta value is. So here you've got a triangle, you have the measurement of one side over here, you have the measurement of another side. One of the trigonometric functions will be sufficient for you to figure out the measurement of that angle. In the next lesson, we will talk more about working with these functions and how you can figure out the adjacent side once you have this information. And any questions that you have, just let me know, and I will address them at some point in a future video. Right now I'm recording them way ahead of time, so your questions won't be answered in the following video, but I will get back to them as quickly as I can. Alright, I hope you guys are understanding what's going on, and I hope you're enjoying it. Hopefully I was right in saying it's not too hard compared to quadratics. I think it's a lot less math once you understand the basics. I know right now it's a little crazy, but it'll get easier, I hope.